Hello again, welcome back to Beginning Algebra. Today we're in section 1.6 and we're going to be talking about multiplying and dividing real numbers. So we're going to learn our sign rules for multiplication and division. First we'll talk about how to find the product of a positive number and a negative number, and then we'll talk about the product of two negative numbers. Then we'll use the reciprocal of a number to apply the definition of division. We'll use the rules for order of operations with multiplication and division, and we will also practice evaluating expressions involving variables. And then we'll translate words and phrases that indicate multiplication and division, and we'll also practice translating simple sentences into equations. So even though the rules for multiplying and dividing are really simple, we have a lot to talk about in this section. So here we go. Now, first of all, the result of a multiplication is called a product. Now, so far we have said that the answer to an addition problem is called a sum. The answer to a subtraction problem is called a difference. And now we see that the answer to a multiplication problem is called a product. You probably already knew that. Remember that multiplying by 0, of course, always gives a result of 0. And that is such an important fact that we actually named it and called it a property. So the multiplication property of 0 just says that x times 0 equals 0, and also 0 times x equals 0. You already knew this, you just may not have ever called it the multiplication property of 0. So this is true for all real numbers. Now, instead of me just giving you the rules for multiplying positives and negatives, let's see if we can determine the pattern by looking at this multiplication table. This is the multiplication table for 3. And notice that we're starting with 4 and we're decreasing that number by 1 each time. So, of course, 3 times 4 is 12, 3 times 3 is 9, 3 times 2 is 6, 3 times 1 is 3, 3 times 0 is 0. Notice that we're decreasing by 3 each time. So in order to continue the pattern here, we would need to say that 0 minus 3 is negative 3. So again, the answer decreases by 3 each time, so it just makes sense that 3 times negative 1 would be negative 3. In fact, a negative times a positive always gives a negative answer. This is different from the rules for addition that we learned. When you're adding and subtracting signed numbers, you have to think about the sign of the larger number. But when you're multiplying signed numbers, it doesn't matter which sign the larger number is. A negative times a positive is always negative. So here's a rule you can memorize. The product of a negative and a positive is always going to be negative. So for example, 6 times negative 3 is negative 18. And also negative 6 times positive 3 is negative 18. See, it doesn't matter which number carries the negative sign. A positive times a negative is negative. Okay, let's practice on a few different examples. Here we have positive 8 times negative 5. Okay, we know 8 times 5 is 40. And we know that positive times negative is negative. So this product will be negative 40. Now on part B we have negative 9 times 1/3. Okay, first let's go ahead and figure out what the sign of the answer will be. This is a negative times a positive, so we know that the result will be negative. Now let's just go ahead and think about multiplying the fractions together. So remember, when we multiply fractions, we do top times top and denominator times denominator. Of course, you cannot see the denominator here, but we know that whenever the denominator is not visible, it's understood to be a 1. So this is going to be top times top is 9 times 1, and in the denominator, 1 times 3 is 3. So now we have negative 9/3, or in other words, negative 9 divided by 3. Of course, we know that 9 divided by 3 is 3, so for our final answer, we will have negative 3. And let's look at part C. Here we have negative 16 times positive 5/32. Of course, negative times positive is going to give us a negative answer. And now let's work on multiplying 16 over 1 times 5 over 32. Now, of course, we don't want to have to multiply 16 times 5 because that's going to become a pretty large number. It's going to be easier for us to simplify here before we actually do the multiplication. I know that 32 is 16 times 2. So I know now that both of these numbers can be divided by 16. 16 divided by 16 is 1. 32 divided by 16 is 2. And so now doing top times top and bottom times bottom, we'll have negative 1 times 5, which is 5, over 1 times 2, which is 2. So our final answer comes out negative 5 over 2. And again, there's no need to convert that to a mixed number because this was not a mixed number problem. Now that we know that a negative times a positive makes a negative answer, let's look at the negative 5 times table and use the same idea that we used last time and see if we can figure out the rule for multiplying a negative times a negative. So when we look at negative 5 times 4, of course, that's negative 20. Negative 5 times 3 would be negative 15. Then negative 5 times 2 would be negative 10. And negative 5 times 1 would be negative 5. Notice that for each of these, we are adding 5 each time. Negative 20 plus 5 is negative 15. Negative 15 plus 5 is negative 10. Negative 10 plus 5 is negative 5. Add 5 to that, you get 0. The pattern is to add 5 each time. So if we add 5 to 0, of course, we get positive 5. So we see that negative 5 times negative 1 has to equal positive 5. The numbers increase by 5 each time, so it makes sense that negative 5 times negative 1 is positive 5. And so here's your rule for multiplying two negative numbers together. The product of two negative numbers is positive, and we saw when we looked at the multiplication table why that makes sense. So in our example here, negative 6 times negative 3 would be positive 18. So now let's practice multiplying two negatives together on each of these examples. Negative 9 times negative 2, of course, is positive 18. We know that negative times negative is positive, and we know that 9 times 2 is 18. Now on part B, we have negative 2/3 times negative 3/2. Let me copy these down here so that we can work with them a little bit. We know that negative times negative is going to make a positive answer, and we know it's always easiest to simplify before we multiply fractions. So let's notice that we have a factor of 2 in the top and a factor of 2 in the bottom. Of course, 2 divided by 2 is 1, so if we divide each of these by 2, they'll both become 1. And we can do the same thing with the 3's. Both of these divide by 3, and so 3 divided by 3 gives us 1 in each case. Now, negative times negative is positive. In the top, 1 times 1 is 1, and in the bottom, 1 times 1 is 1. And so the final answer is positive 1. And let's look at part C. Negative times negative, of course, will be positive. And here, when we look for factors that can be divided by the same thing, we don't get any common factors. So we'll just go ahead and say that top times top is 1 times 5, so that's 5. And bottom times bottom is 7 times 2, so that's 14. And of course, this cannot be reduced, and our final answer here is positive 5 over 14. So now let's summarize our rules for multiplying signed numbers together. The product of two numbers with the same sign is positive. You already knew when we started that positive times positive was positive, and now you know that negative times negative is also positive. So if the two numbers have the same sign, the result will be positive. The product of two numbers with different signs is negative. Now that we've got multiplication nailed down, let's go ahead and talk about the definition of division. Now, the definition of division depends on the idea of a reciprocal, and you may remember this from when we talked about dividing fractions. And I told you that instead of saying reciprocal, sometimes you'll see the word multiplicative inverse. It means the same thing as reciprocal. So what are reciprocals? Well, pairs of numbers whose product is 1 are called reciprocals, or multiplicative inverses. Here are a couple of examples. If we take 5/8 and multiply it by 8/5, the product is 40 over 40, which reduces to 1. So 5/8 and 8/5 are reciprocals of each other. And if we look at negative 9/5 times negative 5/9, negative times negative is positive, and of course we would get 45 over 45, which reduces to 1. So negative 9/5 is the reciprocal of negative 5/9, and the other way around. So again, notice that the reciprocal of a fraction is just that same fraction flipped upside down, but also notice that reciprocals have the same sign. These two numbers are reciprocals of each other and they are both positive. These two numbers are reciprocals of each other and they are both negative. Okay, we've said this before, but remember that the answer to a division problem is called a quotient. Now, of course, quotients can be written with the division symbol like this, but in algebra we prefer to write our quotients in fraction form because it just makes simplifying so much easier. So here's the definition of division. For any real numbers x and y, where y is not 0, we can write x divided by y as x times 1 over y. In other words, to divide two numbers, we just multiply the first one by the reciprocal of the second one. So for example, if we have 15 divided by 3, that can be rewritten as 15 times 1/3. And of course, top times top would give us 15, and bottom times bottom would give us 3. So this looks like a fraction, 15 thirds, but it also is just a division problem. Remember, the fraction bar takes the place of the division symbol. So this could also be read as 15 divided by 3. So this is what I meant when we said that in algebra we prefer to write our division in fraction form. Instead of writing it like this, write it in this fraction form so that it's vertical, so that it's easy to simplify. So now 15 divided by 3, of course, is 5. Let's look at another example. Here we have 12 divided by 5. You might ordinarily tell me, well, I don't know how to do that because 5 doesn't go into 12. So when we look at something like this, if you're just thinking whole numbers, it seems like a difficult problem. But if you just go to fraction form, it becomes much easier. 12 divided by 5 is 12 times 1/5. And we know that 12 times 1 is 12, and in the denominator 1 times 5 is 5. So 12 divided by 5 just gets written as 12/5. Of course, this also says literally 12 divided by 5. So you see how the division form relates to fraction form? This is much easier to handle, and there's nothing to work here. This is done. Now, good news. Because division is defined in terms of multiplication, the sign rules that we learned from multiplication also apply to division. So now, to summarize, we have our rules here for multiplying or dividing signed numbers. The product or quotient of two numbers with the same sign is positive, and the product or quotient of two numbers with different signs is negative. Okay, let's practice with example 3. In part A, we have 8 divided by negative 2. Of course, positive divided by negative is going to give us a negative answer, and 8 divided by 2 is going to be 4. So this quotient is negative 4. Now in part B, we have negative 100 divided by 6. Now at first this might look like a difficult problem because you might be thinking about having to do the old long division algorithm where you make a guess, multiply back and subtract and pull down and all of that stuff. But this is what's nice about fraction form. We won't need to do any of that. All we have to really do is simplify this fraction. So we know that negative 100 divided by positive 6 is going to make a negative result. And now we just need to think about what number goes into both 100 and 6? Well, of course, they're both even, so 2 goes into both of them. 100 divided by 2 would give us 50, and 6 divided by 2 would give us 3. So what we end up with is negative 50 over 3. Now let's look at part C. Here we have negative 35 divided by negative 7. Of course, we know that negative divided by negative is going to give us a positive answer, and we also know that 35 divided by 7 is 5. So that quotient is simply 5. And now on part D, we have negative 1/8 divided by negative 3/4. Notice that this one does show the old division symbol. That's because putting it in fraction form would give us a fraction in the top and a fraction in the bottom. And we're not quite ready for fractions made out of fractions, but you will get there one day. For right now, let's just remember that when we're dividing fractions, we just change divide to times and we flip the second fraction. So this problem will become negative 1/8 times negative 4/3. Of course, when you flip a fraction, it retains its sign. So remember I told you that reciprocals always have the same sign. So this one started out negative. When we flip it over, it's still negative. Now before we multiply top times top and bottom times bottom, let's check for common factors. Here I see a 4, and in the denominator I know that 8 is 4 times 2. So let's divide both of these numbers by 4. 4 divided by 4 would give us 1, and 8 divided by 4 would give us 2. And now we're ready to multiply. Negative times negative will make a positive answer. 1 times 1 is 1 for the top number, and then 2 times 3 is 6 for the bottom number. So our quotient here comes out 1/6. Now let's think about division with 0, and we're going to start out by looking at a problem that does not contain a 0. So here we've got 12 divided by 3. Of course, we know that 12 divided by 3 is 4. And this makes sense because we also know that 3 times 4 is 12. You know that multiplication and division are opposites. So if 3 times 4 is 12, that means 12 divided by 3 has to be 4. Okay, now let's look at a problem that does contain a 0. 0 divided by 3 is actually 0. And this makes sense because we know that 0 times 3 is 0. And think about it this way too. If you have nothing and you divide it among 3 friends, then each friend gets nothing. So this totally makes sense. But now think about this. What would it be if we had 3 divided by 0? Well, it turns out that there is no number we can multiply times 0 to get 3. So 3 divided by 0 does not have an answer, and we say that division by 0 is undefined. You just need to remember that you cannot have a 0 in the denominator. 0 in the numerator is fine. 0 divided by any number is still 0. But 0 in the denominator is not okay, because we're not able to get an answer from dividing by 0. That's what we mean by undefined. So one more time, for any real number x, as long as x is not equal to 0, 0 divided by any number is 0. That's fine. And any number divided by 0 is going to be undefined. Now let's talk a little bit about equivalent forms. For any two numbers x and y, if you have negative x divided by positive y, of course that result is negative. You know that when the signs are different, you get a negative answer. So that's the same as having positive x over negative y. As long as the signs are different, the quotient is negative. And that can also be written as a negative in front of the fraction. All 3 of these forms have the same value. However, it's not standard practice to leave negatives in the denominator. So this form you might see in a problem, but we would never leave an answer in this form. Whenever you have a fraction as your answer and that fraction is negative, you should either leave the negative in the top of the fraction or put the negative in front of the fraction. Either way is acceptable, but never leave the negative in the denominator. Okay, now let's practice our rules for order of operations. Remember PEMDAS, P-E-M-D-A-S. So we know that multiplication and division come before addition and subtraction. So when we look at part A here, negative 9 times 2 minus negative 3 times 2, we know that multiplication has to be done before subtraction. So let's go ahead and underline our two multiplications that we're going to do. Because they do not affect each other, we can do them at the same time. So here I have negative 9 times 2. I know that that is negative 18. Then minus. And here we have negative 3 times 2. I know that that is negative 6. Okay, now I'm going to convert this subtraction to addition. So negative 18 minus negative 6 becomes negative 18 plus positive 6. And now I can see that the signs are different, and I'm going to subtract and use the sign of the larger number, which is negative. 18 minus 6 is 12, and the answer should be negative, so negative 12. Now let's look at part B. Here we have negative 6 plus 2 times 3 minus 5. And again, we have to decide what to do first. So we think about PEMDAS, and we know that P stands for parentheses or grouping symbols. And I see that we have an operation here inside this grouping symbol. So let's do that first. 3 minus 5 is the same as 3 plus negative 5. And of course, that's going to be negative 2. So we're going to have here negative 6 plus 2 times negative 2. Okay, now we have to decide what to do here. And we know that multiplication comes before addition, so we should perform this multiplication. 2 times negative 2 is going to be negative 4. So now we have negative 6 plus negative 4. And when we add two negatives, we add the numbers and keep the negative sign. So negative 6 plus negative 4 is going to add up to negative 10. And here we have part C. We have 5 times negative 2 minus 3 times 4, all divided by 2 times 1 minus 6. So remember, this is the type of problem where we work the top separately from the bottom and then we put the two together at the end. So I'm going to go ahead and make a space here for the top and the bottom. Of course, the top is 5 times negative 2 minus 3 times 4. We should perform multiplication before subtraction. So let's do both of these multiplications at the same time. 5 times negative 2, of course, is negative 10, and then minus 3 times 4 is 12. Now we have negative 10 minus 12. You can convert that to addition by saying negative 10 plus negative 12, and now you can see that both numbers are negative. So we add and keep the negative sign. That's going to give us a total of negative 22 for the top. Then in the denominator, we have 2 times 1 minus 6. Of course, we should perform the subtraction inside the parentheses first. So we can think of this as 1 plus negative 6, and we know that the signs are different, so we'll have to subtract and use the sign of the larger number. So 1 minus 6 is going to be negative 5. So 2 times this parentheses becomes 2 times negative 5, and of course we know that that is going to be negative 10. Okay, now putting it all back together, the top divided by the bottom would be negative 22 over negative 10. Of course, negative divided by negative is going to give us a positive result, and there's not going to be a whole number answer here, but we can simplify this fraction. Both of these numbers can be divided by 2. So 22 divided by 2 is 11, and 10 divided by 2 is 5. For our next example, they're going to give us some expressions that contain variables, and here they're telling us that x equals negative 1, y equals negative 2, and m equals negative 3. And it says evaluate each expression for these values. And of course, we know evaluate means plug in these given values and use order of operations to find the value of the expression. So let's go ahead and write this as 3 times negative 1 plus 4 times negative 2 times negative 2 times negative 3. Now you'll notice that I broke out the brackets here. That's because since I'm plugging in negative numbers, I knew I wanted to use my parentheses to represent multiplication, and that meant that these parentheses needed to be represented by brackets instead, just to keep the brackets and parentheses from getting mixed up. So now let's go ahead and think about order of operations. So PEMDAS says work any operations that are inside the grouping symbols first. So we need to work the operations that are inside the brackets. Let's go ahead and do all three multiplications here. Here I've got 3 times negative 1, which is negative 3, then plus 4 times negative 2, so that's going to be negative 8, and then times negative 2 times negative 3, which is positive 6. And since I no longer need two pairs of grouping symbols here, I've just reverted back to parentheses for this one. Okay, now working on the addition inside this bracket, we have negative 3 plus negative 8. That's going to add up to negative 11. And so now we have negative 11 times positive 6. Negative times positive is negative, so we're going to end up here with negative 66. Now let's look at part B. So we have here 2 times x squared minus 3 times y squared. Of course, we are substituting negative 1 in place of the x and negative 2 in place of the y. Okay, now remember your order of operations. First, do any operations inside grouping symbols. I do have grouping symbols here, but no operations inside them to do. And then we do exponents next. So I do have a couple of exponents here. Let's go ahead and take care of those. Negative 1 squared is negative 1 times negative 1. That's going to be positive 1. Then minus 3 times negative 2 squared. Now negative 2 times negative 2 is positive 4. So now we have 2 times 1 minus 3 times 4. At this point we can go ahead with multiplication. So 2 times 1 will be 2, minus 3 times 4 is 12. So now we have 2 minus 12. That's equivalent to 2 plus negative 12. We can see that the signs are different, so we subtract and use the sign of the larger number. And 2 plus negative 12 will be negative 10. I hope that you're finding as we do these that the more you do them, the easier they get for you. This is a type of problem that just takes practice. The more you use your rules for adding, subtracting, multiplying, and dividing signed numbers or fractions, the better you will remember them and the fewer mistakes you will make. So keep practicing. That is the key to the entire thing here. In part C, we've got 4y squared plus x all over m. So let's go ahead and recopy this. Remember, y is negative 2, x is negative 1, and m is negative 3. So we're going to have 4 times negative 2 squared plus negative 1, all divided by negative 3. Now remember, we normally work the top and the bottom separately, but in this case, there's really nothing to do in the denominator, so it's all about the top here. So let's decide what to do first. We have 4 times negative 2 squared plus negative 1. Of course, thinking about order of operations, we need to do the exponent first. Negative 2 times negative 2 is going to be positive 4. And then we notice that we have multiplication and addition left in the top, so we should do the multiplication first. 4 times 4, of course, will be 16. So now we have 16 plus negative 1 all over negative 3. And then 16 plus negative 1 is going to be 15. And 15 divided by negative 3 is going to give us negative 5. Now for part D. Let's copy the problem over and plug in our given values. So we'll have 3/4 times negative 1 plus 5/8 times negative 2, and then times negative 1/2 times negative 3. And again, notice that I have replaced these parentheses with brackets because I wanted to use the parentheses as a multiplication symbol. Okay, now I'm going to go ahead and do each of these multiplications. 3 times negative 1 is going to be negative 3, and that's over 4. 5 times negative 2 is going to be negative 10, and that's over 8. And then times negative 1/2 times negative 3 is going to be positive 3 over 2. You see, negative 1 times negative 3 would be positive 3, and 2 times 1 would be 2. Okay, now we know that we need to do this addition before we try to do multiplication. And we know that when we add fractions, we need a common denominator. Now you could change this 4 to an 8, but we are in luck. And notice that 10 over 8 will reduce. Both of these numbers can be divided by 2, and if we do that, then we'll have common denominators. They'll both be 4. So 10 divided by 2 is 5, and 8 divided by 2 is 4. That's going to give us negative 3/4 here plus negative 5/4 times 3/2. Okay, now negative 3/4 plus negative 5/4. We know that when we add fractions, we add the numerators. So that's going to make negative 8/4, and it's still times 3 over 2. Now before we start multiplying, let's see what we can think of that will reduce. There are a couple of different options here, but I noticed that 8 and 2 can both be divided by 2, so I'm going to do that. 8 divided by 2 is 4, and 2 divided by 2 is 1. Now let's see where we are. I'm not going to work this yet, but I'm just going to recopy it. Here we've got negative 4 over 4 times 3 over 1. Okay, now I notice that 4 divided by 4 is just 1. So let's cross out those 4's, and we'll end up with just negative 3 over 1. But remember, when the denominator is 1, it's not necessary to write it. So that's just plain old negative 3. Okay, now we're ready to move on and talk about some words and phrases that indicate multiplication. Of course, words like product of, we know product means multiplication. Times, we use that one a lot. Twice just means 2 times. Triple means 3 times. The word of in a math problem usually indicates multiplication. So we'll talk about that in just a minute. And as much as is another one that you might not think of as often as some others. So let's practice a few examples here. The product of negative 5 and negative 2. Okay, product is multiplication, so we would just write negative 5 times negative 2. Of course, that works out to positive 10. 13 times negative 4. Okay, we just write it just like it sounds. And positive times negative is negative. 13 times 4 is 52, so this would be negative 52. Twice 6, you would just write 2 times 6. Of course, that's 12. Triple 4, you would just write 3 times 4. Of course, that is also 12. 1/2 of 10. So the word of frequently indicates multiplication, so we would write 1/2 times 10. Of course, when you multiply here, you'll see that 1 times 10 is 10, and in the denominator, 2 times 1 is 2. So this really just says 10 divided by 2, which we know is 5. And then 2/3 as much as 30. So 2/3 times 30. We could simplify this by saying that 30 and 3 can both be divided by 3. So let's do that. 30 divided by 3 is 10. 3 divided by 3 is 1. And we're going to end up with 2 times 10 in the top, so that's 20, and 1 in the denominator. And we know that whenever the denominator is 1, we don't have to write it. So the final product here is just 20. Now let's practice writing these expressions. The product of 12 and the sum of 3 and negative 6. So we know that product indicates multiplication, so we're going to be multiplying 12 times this sum. So let's write the sum down first. The sum of 3 and negative 6. So we'll write 3 plus negative 6. Now we want to multiply 12 times all of this. So let's put it in brackets and put the times 12 in front to indicate multiplication. Okay, now working this out, we know that we should do the addition first because it's inside the grouping symbol. 3 plus negative 6 is negative 3, and then 12 times negative 3 would be negative 36. On part B, we have twice the difference of 8 and negative 4. So we know that twice means 2 times. So let's first start by writing the difference of 8 and negative 4. Difference means subtraction. So we'll say 8 minus negative 4. Now we want to write twice that. So this whole quantity needs to be multiplied by 2. So let's put that in brackets and multiply it by 2. And now let's work this. the difference of 8 and negative 4, we know that 8 minus negative 4 would be 8 plus 4, and 8 plus 4 is 12, so we have 2 times 12, which is 24. Here is part C. We have 2/3 the sum of negative 5 and negative 3. So even though it's not explicitly stated, we could say 2/3 of the sum of negative 5 and negative 3. We know that this is going to be multiplication. So let's start by writing the sum of negative 5 and negative 3. We'll just write negative 5 plus negative 3. Now I want to get 2/3 of that. So we'll put that in brackets and multiply it by 2/3. Now let's work what's inside the grouping symbols first. We know that negative 5 plus negative 3 is negative 8. So that gives us 2/3 times negative 8. And now we need to multiply this fraction times this integer. So we always look for common factors that we can cancel out, but here we will not find any because of course 3 does not share any factors with 8, and of course the denominator here is 1. So all we can do is top times top, which is negative 16, and bottom times bottom, which is 3 times 1, which is 3. And remember that positive times negative is negative, so we have ended up here with negative 16/3. This cannot be reduced, and there's no need to convert it to a mixed number form. So this is our final form. And then on part D, we have double the product of 3 and 4. Of course, product indicates multiplication, so we could start by writing 3 times 4, and then double that would just be 2 times that. So we'll take that whole product and multiply it by 2. Now working from inside the grouping symbols first, 3 times 4 is 12, and 2 times 12 is 24. Now let's look at a few phrases that indicate division. We know that a quotient is a division. You also will see divided by sometimes or ratio of. So the quotient of negative 24 and 3 would be written negative 24 divided by 3. Of course, when you simplify that, that would be negative 8. 24 divided by 3 is 8. And when we say divided by, we have negative 16 divided by negative 4. Of course, that would be negative 16 divided by negative 4 to put it in fraction form. We know that negative divided by negative is positive, and we know that 16 divided by 4 is 4. And the ratio of 2 to 3 would just be written as 2 over 3. That's all there is to that. So just a reminder, when translating a phrase involving division into a fraction, we write the first number as the numerator and the second number as the denominator. So here's a chance for us to practice translating words that represent division. Part A says the quotient of 14 and the sum of negative 9 and 2. So this is going to be a division with 14 in the top and this sum in the denominator. So let's write 14 in the top and the sum of negative 9 and 2 in the bottom. So that will be negative 9 plus 2. Now I put these parentheses on here kind of out of habit because that's what we've been doing, but you need to know that because of the fraction bar here, the parentheses really aren't adding anything to this, so we could leave them off. You might write it like this. Now let's go ahead and simplify here. We know that we work the top and the bottom separately. There's nothing really to do in the top, but in the bottom, negative 9 plus 2 would be negative 7. That leaves us with 14 divided by negative 7. We know that positive divided by negative is a negative answer, and we know that 14 divided by 7 is 2. So we're going to come up here with negative 2. And now part B, the product of 5 and negative 6 divided by the difference of negative 7 and 8. So this divided by is going to be our fraction bar. In the top, we'll have the product of 5 and negative 6, and then in the denominator, we'll have the difference of negative 7 and 8. Remember, difference means subtraction, so negative 7 minus 8. Okay, now simplifying the top and the bottom separately, we know that 5 times negative 6 is going to be negative 30, and we know that negative 7 minus 8 is the same as negative 7 plus negative 8. That's going to add up to negative 15. and that's going to give us negative 30 divided by negative 15. Negative divided by negative, of course, is positive, and 30 divided by 15 is 2, so we come up here with positive 2. And here we have example 8, translating sentences into equations. Now remember, an equation is a sentence, and it's a way of saying one thing is the same as another thing. So equations are always going to have the word is, and these instructions say write each sentence as an equation using x as the variable. So part A says 3 times a number is negative 18. So of course for the number we will use x, and we'll just write 3 times that number is negative 18. So this is how it looks in equation form. 3 times a number is negative 18. On part B, the sum of a number and 9 is 12. So for the number we'll use x, and of course sum means addition. So the sum of a number and 9 is 12. X plus 9 equals 12. Notice that they did not ask us to solve these equations. We have not yet learned how to solve equations. So even though you might know how to solve from a previous algebra class, they have not asked us to do that here. So we're just asked to write the equation, and that's all. So part C says the difference of a number and 5 is 0. So difference means subtraction. So we'll write x minus 5 equals 0. And on part D, the quotient of 24 and a number is negative 2. Remember, quotient means division. So 24 divided by a number, so divided by x, equals negative 2. 24 divided by x equals negative 2. Okay, here's just a reminder that an expression is like a phrase. We did some of those in examples 6 and 7, but an equation is a sentence, like the example that we just finished. For a sentence to represent an equation, it must contain the word is. An example of an expression might be something like 7 times a number plus 3. You cannot figure out what that number is because we don't know what the total is. But in an equation, you'll always have an equal sign. So 7 times a number plus 3 equals 28. In this case, we would eventually be able to figure out what x would have to be for this equation to be true. So this is an equation and this is an expression, and you can tell that this is not an equation because it does not have an equal sign. And you can tell that this is an equation because it does have an equal sign, and when you read it, 7 times this sum is 28. It contains the word is.